Okay, hello everyone in a new video. So in this one we are going to complete the explanation of chapter 3, which is the DC voltage and the second unit of electricity. So we have reached part 2. Then now we are in section number 7, and the title of this section is the voltmeter. Okay, so here in the figure we have the voltmeter. So what is the voltmeter? Okay, the voltmeter is an instrument that is used to measure the voltage across an electric component in a given electric circuit. So first, before discussing the voltmeter, let's give the symbol of the voltmeter. So idea number 1, the symbol. Okay, because the name of this instrument is the voltmeter, then here the letter V represents the voltmeter. Okay, the voltmeter has two terminals, and one of the terminals has the name given by the COM. Okay, later we will discuss why one of the terminals is named by the COM. Now idea number 2, what is the voltmeter? The voltmeter is an apparatus okay, the word apparatus means that it is an instrument which is used to measure the voltage across 2 points of an electric circuit. Okay, from its name, the name of the instrument is given by the voltmeter, and notice that it ends with the word meter. Always whenever the word ends with a meter, this means that is an instrument used to measure something. Okay, and because it starts with a volt, means that this is an instrument that measures the voltage. Okay, so the voltmeter is an instrument used to measure the voltage across 2 points of an electric circuit or across an electric component. Now idea number 3, how do we connect the voltmeter? The voltmeter has two terminals. These are the terminals of the voltmeter. This is the first terminal, and the other terminal is this one, which is named the COM. And how do we connect the voltmeter? And it must be connected in parallel. Suppose that here we have a battery. Okay, we have a lamp, and we have a motor arm, or let's suppose another lamp. So this is the lamp L1, this is the lamp L2, and the lamp L2 is connected to the negative pole of the battery. Now suppose that this battery has a voltage of 9 volts, the lamp L1 has a voltage of 3 volts, and the lamp L2, so this is 3 volts, and the lamp L2 has a voltage of 6 volt. Okay, now suppose that we need to measure the voltage across the lamp L1 using the voltmeter. Here they are telling me in idea number 3 that the voltmeter has two terminals and it must be connected in parallel. Okay, so this is the connection of the voltmeter, and this is the COM terminal. And we always connect the voltmeter in parallel, because we know that always whenever two electric components are in parallel, then they have the same voltage. Then in this case, the voltmeter measure the voltage of the lamp L1. Now if you want to measure the voltage of the lamp L2, then we connect the given voltmeter in parallel with the lamp L2, like this. And this is the COM terminal. Now notice that the lamp L2 and the voltmeter are in parallel, because this is the first terminal of the lamp connected to the first terminal of the voltmeter, and the second terminal of the lamp is connected to the COM terminal of the voltmeter. Now idea number 4. Now let's discuss what does the COM terminal represent. Okay, we have two cases. If the COM terminal is connected to the negative pole, then the voltmeter will indicate positive reading. So if the COM terminal is connected to the negative pole, then the voltmeter will indicate positive reading. So notice that here in the electric circuit, the voltmeter is measuring the voltage across the lamp L2, and the COM terminal in this case is connected to the negative pole of the battery. This is the positive pole of the battery, and this is the negative pole of the battery. So in this case, the COM terminal is connected to the negative pole, like this. Then in this case, they are telling me here, if the COM terminal is connected to the negative pole, then the voltmeter will indicate positive reading. Then in this case, the reading of the voltmeter, because it's measuring the voltage across the lamp L2, so it will be 6 volt. And because the COM terminal is connected to the negative pole, then the voltmeter will indicate positive reading, so it's the opposite. So this will be plus 6 volt. Now what happens if we reverse the connection of the voltmeter? What happens now if the COM terminal is here? Then idea number 5, if the COM terminal is connected to the positive pole, then the voltmeter will indicate negative reading. So now what we will do is that we will reverse the connection of the terminals of the voltmeter. So now in this case, the COM terminal is here. So the COM terminal in this case is connected to the positive pole of the battery. And here they are telling me if the COM terminal is connected to the positive pole, then the voltmeter will indicate negative reading. Now the voltmeter is measuring the voltage across the lamp L2, so the voltage measured by the voltmeter is given by 6 volt. And because the COM terminal is connected to the positive pole, from idea number 5, then the voltmeter will indicate negative reading. So here on the screen of the voltmeter, it will indicate negative 6 volt, and this is because the COM terminal is connected to the positive pole. So always the voltmeter measures either positive or negative voltage, and this depends on the COM terminal. Now idea number 6, if the COM terminal is connected to B, say for example, and the other terminal is connected to A, Then the voltmeter measures UAB. Okay, let me give an example here. Okay, suppose that here we have a battery. So this is the lamp L1. This is the lamp L2. And this is another lamp L3. And the lamp L3 is connected back to the negative pole of the battery. Notice that in both examples of these electric circuits, both of them are classified as a closed circuit, although we don't have a closed switch, but notice that all the electric components are connected to each other. Now let's name the different terminals in this circuit. Let's suppose that this is the point P, this is the point A, this is the point B, this is the point C, this is D, and this is N. Now suppose that here we have a voltmeter measuring the voltage across the lamp L1. Okay, and this is the COM terminal. So we know now that the voltmeter is measuring the voltage across the lamp L1 because it's connected in parallel with the lamp L1. Now the question is that the voltmeter, does it measure UAB, which is the voltage across the lamp L1, or UBA? Because UAB or UBA, both of them are voltages across the lamp L1. In order to know which one of them does the voltmeter measures, we need to refer to the COM terminal. So here in idea number 6, they are telling me if the COM terminal is connected to B and the other terminal is connected to A, then the voltmeter measures UBA. So notice that the second letter corresponds to the COM terminal. Okay, now here the COM terminal is connected to B, so this is the second letter, which is B. Then the oscilloscope measures, the voltmeter measures UAB. Okay, now if the COM terminal is connected to the terminal A, so in this case, what does the voltmeter measures, UAB or UBA? Now here the voltmeter is measuring the voltage across the lamp L1, which is given by U. Because the COM terminal is connected to A, then the voltmeter measures UBA. So always the second letter corresponds for the COM terminal. So this is the answer. Now suppose that here we connect the voltmeter to the lamp L3 like this, and the COM terminal is connected to the terminal T. Now what does the voltmeter in this case measures, UCD or UDC? Now the COM terminal is connected to the point D, therefore the voltmeter measures UCD. So always the second letter corresponds for the COM terminal. Now if the COM terminal is placed here, then in this case, what does the voltmeter measures, UCD or UDC? Then in this case, the voltmeter measures UDC because simply the COM terminal is connected to the C terminal. Okay, so this is it for the voltmeter. Now let's discuss the other instrument, which is given by the ammeter. Now section number 8, the ammeter. Okay, from its name, ammeter, so am stands for amperes, which is the unit of the electric current, And meter represents, or it's a keyword to indicate that ammeter is an instrument. So the ammeter is an instrument that measures the electric current. Let's give it a symbol. This is the ammeter. It has the same shape of the voltmeter. So this is the voltmeter. The voltmeter and the ammeter are very similar in shape. Let's give it a symbol. The letter A stands for the ammeter. Similar to the voltmeter, the ammeter has a COM terminal. So what does the ammeter, or what's the role of the ammeter, or what's used for? The ammeter is an apparatus which measures the current across 2 points of an electric circuit. Okay, now how do we connect the ammeter? The ammeter has 2 terminals. And it must be connected in series. And it must be connected in series because we know that in series the current is the same. Now suppose here we have a battery connected to a lamp L1. And here we have another lamp L2 connected back to the battery. So this is a closed circuit. This is the positive pole and this is negative pole. Then the battery will deliver electricity to both electric components, and the direction of the electric current is from the positive pole to the negative pole, like this. Okay. Now I here is set to be the main current, which is equal to the current I1 traversing the lamp L1 and equal to the current I2 traversing the lamp L2 according to law of uniqueness of currents. Now suppose that here in this case we need to measure the current I traversing this circuit, which is the same. So the ammeter has 2 terminals and it must be connected in series. Then we can connect the ammeter like this here. Then in this case the ammeter will measure the current I traversing this circuit, which is equal to I1, which is equal to I2. And let's place the COM terminal to be here. Now idea number 4. The voltage across an ammeter is 0 because it is of negligible resistance. Now let's name some terminals here. Suppose that this is the point P, this is the point A, this is the point B, this is C, and this is N. Here in idea number 4 they are telling me that the voltage across an ammeter is 0 because it's of negligible resistance. Then we can ask the following question: what's the voltage across the ammeter, which is given by UPA? So by definition UPA is equal to 0 because it's the voltage across an ammeter. Let me write UPA is equal to 0. Then by definition the voltage across an ammeter is 0 because it is of negligible resistance. The word negligible means almost 0 or equal to 0. Okay, and the word resistance, we need to wait for the next chapter in order to explain what's the meaning of resistance. Now let's take it for granted. Whenever we are asked about the voltage across the ammeter, we directly say it is 0 because it's of negligible resistance. Now idea number 5, if the COM terminal is connected to the negative pole, then the ammeter will indicate positive reading, which is similar to the case of the voltmeter. So if the COM terminal is connected to the negative pole, then the ammeter will indicate positive reading. Now suppose that here in this circuit the value of the electric current is given by I, for example 0.5 amperes. Now the ammeter will measure this current, so the indication of the ammeter will be 0.5 amperes. Now we need to know whether this indication is positive or negative, and in order to know so, we refer to the connection of the COM terminal. So here the COM terminal is connected to the negative pole of the battery, and whenever the COM terminal is connected to the negative pole, then the reading of the ammeter will be positive. Therefore this reading is positive. And now idea number 6, if the COM terminal is connected to the positive pole, and we know now in this case, then the ammeter will indicate negative reading. Now suppose that here we reverse the terminals of the ammeter. So now the COM terminal is connected to this terminal, which is the terminal P. Now what will be the indication of the ammeter? The ammeter is measuring the current I delivered by the battery, and it has a value of 0.5 amperes. And now because the COM terminal is connected to the positive pole, then the reading of the ammeter will be negative, so minus 0.5 amperes. Then this is it for the ammeter and for the voltmeter. Both of them are instruments that are used to measure properties across different electric components. Now let's solve some exercises as a direct application on what we have explained. Then exercise number 3. They are telling me consider the above electric circuit consisting of a battery of 12 volts and a lamp L. Always whenever solving such type of exercises, it's better to write the given voltage on the circuit. So here they are telling me that the battery is of 12 volts. So this is 12 volts, the value of UG. Now in number 1 they are telling me what is the voltage across the lamp. Justify. Notice that here the lamp and the battery are connected in parallel, and this is because these are the two terminals. This is the first terminal of the battery connected to the first terminal of the lamp, and the second terminal of the battery is connected to the other terminal of the lamp. Therefore both terminals are connected to each other, then the lamp and the battery are in parallel. Then we can say then the battery and the lamp are in parallel. And we know that whenever two electric components are in parallel, they have the same voltage. Because the battery is of 12 volts, then the voltage across the lamp will be 12 volts. And here we need to mention the law. Always in physics, whenever we use a law, we need to mention the law. Then according to law of uniqueness of voltages. They have the same voltage. Therefore, U of the lamp is equal to UG, which is U of the battery, which is equal to 12 volts. Now in number 2, they are telling me add a voltmeter that allows us to measure the voltage across the lamp such that the COM terminal is connected to the positive terminal. Then let's redraw the circuit. This is the battery. This is the lamp. Okay, this is UG. They are telling me add a voltmeter that allows to measure the voltage across the lamp. So we are measuring the voltage across the lamp, and we know that the voltmeter must be connected in parallel. So this is the voltmeter. Now it's left to indicate the COM terminal. They are telling me that the COM terminal must be connected to the positive terminal. This is the positive terminal of the battery. Then we go to the voltmeter. So the COM terminal must be here. So this is it for number 2 done. Now in number 3, they are telling me connect an ammeter that allows to measure the current such that it indicates positive reading. So here the current I, which is delivered by the battery like this. Okay, and then we need to measure this electric current I using the ammeter. Now we have two choices. Either we can connect the ammeter to be here or connect the ammeter to be here. Let's place it in this case to be here. So this is the ammeter. Now it's left to represent the COM terminal. Notice that here they are telling me such that it indicates positive reading, and in order for the ammeter to indicate positive reading, the COM terminal must be connected to the negative pole. This is the negative pole of the battery going to the ammeter, so the COM terminal must be located here. Then this is it for exercise number 3. Now in exercise number 4, in order to measure the voltage UBC across D, we use a digital voltmeter. Okay, number 1. So here in the electric circuit, we have a battery and an electric component D. Here they didn't specify what is the electric component D. It may be a lamp, a motor, we don't know, or a switch. Now this arrow on the battery means that the voltage across the battery can be adjusted. So it can be, for example, 3 volts, 5 volts, 7 volt or 8 volts. So we can adjust the value of this battery. Okay, now the arrow is not very important in this case. Now in number 1, they are telling me represent this voltmeter on the redrawn figure indicating its V and COM terminal. Then let's redraw the electric circuit. This is the electric component D. And this is the voltage UG. Now here they are telling me in order to measure the voltage UBC. This is important. Across D. So we need to connect the voltmeter such that it measures the voltage across the electric component D. Therefore the voltmeter must be connected in parallel with the component D. Now it's left to indicate the COM terminal. Here they are telling me that in order to measure the voltage UBC, and always the second letter corresponds for the COM terminal. So this is the terminal C, therefore the COM terminal must be connected here. Okay, and they are naming the other terminal to be V, so we can name this terminal to be V, but the important terminal is the COM terminal. Now in number 2 they are telling me UPB is equal to 0 volt, so they are asking me about the voltage across the terminals P and B. Notice that across P and B we have a wire, and we know that always the voltage across a connecting wire is 0. Then let's say the voltage across a connect is 0. For this reason UPB is equal to 0 volts. Now here the unit is not important, because 0 multiplied by anything will remain 0, so we can say like that, 0 volt, which is equal also to 0. Then now number 3 they are telling me show that UPN is equal to UBC. So we need to show that UPN is equal to UBC. And this is done by using the law of addition of voltages. Apply law of addition of voltages. And how do we know that we must apply the law of addition of voltages in order to show that UPN is equal to UBC? Notice that here in number 2 they are asking me about the voltage across a certain branch. So whenever they ask me the voltage across a certain branch, for example UPB or across PB or NC, and later on they ask me to show UPN is equal to UBC, or to show that UPN for example is equal to 12 volts, then here we must directly deduce that we need to use the law of addition of voltages. Then let's apply this law. Then on the left we'll write the voltage of the battery, which is given by UPN, and on the right we'll write the voltages across all different components, starting with P and ending with N. So UP, now we go to the point B, plus UB, now we go to the point C, plus UC, and now we go to the point N, and by this we have ended with the point N. Now we already know the value of UPB is 0 from part 2, plus we will leave UBC as it is, and now the value of the voltage UCN is also 0, because across C and N we have a connecting wire, and from part 2 we know that the voltage across a connecting wire is 0, and this will give me UBC, which means that UPN simply equals to UBC. And this is very clear, because notice that here the battery and the electric component D are in parallel, because the first terminal of the battery is connected to the first terminal of the electric component, and the other terminal of the battery, which is the negative pole, is connected to the other terminal of the electric component D. Therefore the battery and the electric component D are in parallel, and this is due to law of uniqueness of voltages. Then this is it for exercise number 4. Now let's solve exercise number 5. They are telling me consider the above electric circuit consisting of a battery, a lamp, a switch, and connecting wires, and an ammeter. Okay, now here in this case the switch is open. Number 1 they are telling me is the switch opened or closed. From the figure we can know that the switch is open, so opened. And they are asking me is there any current flowing in this circuit. Then because the switch here is open, now this circuit is classified as an open circuit, and we know that in an open circuit the value of the electric current I is 0. Then let's say an open switch doesn't allow electric current to pass through. Therefore the value of the electric current is 0. Now in number 2 they are telling me now we close the switch. Let's close the switch. What will be the indication of the voltmeter? So here it's not given the value of the current. Let's consider it to be, for example, 0.75 amperes. So this is given. Now they are telling me what will be the indication of the ammeter. So notice that here the COM terminal is connected to the negative pole. Let's say since the COM terminal is connected, then in this case, then the ammeter will indicate positive reading. Here the ammeter is measuring the current I, which is traversing the lamp, and the value of this current is 0.75 amperes. Because the COM terminal from the figure is connected to the negative pole, therefore it will measure 0 plus 0.5 amperes. However, if the COM terminal was connected here to the positive pole, then the indication of the ammeter will be minus 0.75 amperes. Now in number 3 they are telling me the lamp and the ammeter are traversed by the same current to justify. And this is because the lamp and the ammeter are in series, and we know that according to law of uniqueness of currents, whenever two electric components are in series, they are traversed by the same electric currents. Then let's say the lamp and the ammeter are in series. According to law of uniqueness of currents, they have the same current. Then this is it for exercise number 5. Now let's move to the next section, which is the oscilloscope. Now we are in section number 12, and the title of this section is given by the oscilloscope. Now here in this figure we have the oscilloscope. Then what is the oscilloscope? The oscilloscope is an instrument used to measure the voltage by visualizing it. This is the screen of the oscilloscope. Okay, this is the screen of the oscilloscope, and this is the oscilloscope. Then before we start discussing how to use this instrument, let's give it a symbol. Then idea number 1, the symbol of the oscilloscope. This is the symbol of the oscilloscope. Now idea number 2, let's define the oscilloscope. What is an oscilloscope? The oscilloscope is an apparatus which measures the voltage by visualizing it with respect to time. Then the role of the oscilloscope, or the use of the oscilloscope, is the same as that of the voltmeter. The voltmeter measures the voltage as well as the oscilloscope. Now when we are measuring the voltage using the voltmeter, the voltmeter will indicate the number. The number indicated on the voltmeter represents the voltage. Now if we are measuring the voltage using the oscilloscope, here on the screen of the oscilloscope, a luminous line will be displaced either upward or downward like this, and this line represents the voltage measured using the oscilloscope. Now we will describe how to read the voltage using an oscilloscope. Then let's talk about the terminals of the oscilloscope. The oscilloscope has two terminals. And how do we connect it? Because we are measuring the voltage, similar to that of the voltmeter is connected in parallel. Therefore, also the oscilloscope must be connected in parallel. The oscilloscope has two terminals and it must be connected in parallel. Now, idea number 4, what are the terminals of the oscilloscope? Then the first terminal, which is given by the phase terminal, or also we call it to be the input channel, which is given by this one. So the symbol of the phase terminal is given by this. It is like a connecting wire but having an arrow. And the other terminal, which is this one, we call it the mass terminal or the ground terminal. Now we come to the idea that discusses how do we measure the voltage using the oscilloscope. Then the measurement of the voltage using the oscilloscope is done using the formula which is given by U is equal to SV multiplied by Y. Then here U represent the voltage measured by the oscilloscope, SV is the vertical sensitivity, and the Y is the number of division of the displacement of the luminous line. So let's define each quantity, where U is the voltage measured by the oscilloscope, and its unit is given by V, which means volts. Now here I am writing the SI unit. Now SV represents for the vertical sensitivity, Okay, what's the unit of the vertical sensitivity? It's given by volts per division, which means, okay, volts per division. And now Y is the number of divisions of the displacement of the luminous line and the unit of Y is given by divisions. Now this is the screen of the oscilloscope, which is here. It is represented in this figure. So now here we are looking at the screen of the oscilloscope. So how do you use the screen in order to determine the voltage measured by the oscilloscope? Now this is the luminous line. So on the screen of the oscilloscope we will observe a luminous line that's displaced either upward or downward. Now suppose that we need to calculate the voltage U measured by the oscilloscope. Now the vertical sensitivity must be given. Now suppose here that the vertical sensitivity is given by 2 volts per division, and we need to calculate the voltage U measured by the oscilloscope. Then according to the formula, U is given by SV multiplied by Y. Now we know that SV is given by 2. Now referring to the screen of the oscilloscope, let's find out the value of Y, which corresponds to the number of divisions of the displaced luminous line. Now because the luminous line is displaced upward, this means that the value of Y is positive, and the number of divisions displaced by the luminous line is given by 1, 2, and each subdivision corresponds to 0.2, so 0.2 and 0.2, this will give me 0.4, so 1, 2, 2.4, then a plus 2.4. Now plugging this on the calculator will give me 4.8 volts. Then the voltage measured by the oscilloscope is given by U is equal to 4.8 volts. So let me say here that idea number 6, screen of the oscilloscope. Now idea number 7 is given by if the phase terminal is connected to terminal A and the mass terminal is connected to terminal B, then the oscilloscope measures UAB. So what does this mean? Suppose here that we have a battery like this. This is a lamp and this is a motor. Now let's name the terminal. This is the positive pole, this is the negative pole, this is the point A, this is the point B, and this is the point C. So now we are interested in calculating the voltage across the lamp using an oscilloscope. Then let's connect the oscilloscope to the lamp. So this is the phase terminal and this is the mass terminal. Then now we can ask the following question: what does the oscilloscope measures, UAB or UBA? And this depends on the connection of the phase and the mass terminal. Now here they are telling me if the phase terminal is connected to A and the mass terminal is connected to B, then the oscilloscope measures UAB. So always the first letter correspond to the phase terminal. Notice that here the phase terminal is connected to A, then the first letter is given by A, and the mass terminal is connected to B, then the second letter is B. So always the oscilloscope measures from the phase terminal to the mass terminal. In this case, the oscilloscope measures the voltage UAB. Now suppose that the oscilloscope is connected across the motor. Then the oscilloscope is measuring the voltage of the motor. In this case, we can ask the following question: what does the oscilloscope measures, UBC or UCB? And this depends on the connection of the phase and mass terminal. Then the oscilloscope is measuring the voltage U across the motor. So always the first letter corresponds to the phase terminal, which is given by C, and the second letter corresponds to the mass terminal, which is given by B. Then the oscilloscope in this case measures UCB across the motor. So always from the phase terminal to the mass terminal. Now idea number 8. If the luminous line is displaced upward, then the oscilloscope measures positive value, which means that the voltage measured by the oscilloscope is positive. Notice that here, when I have calculated, when I was finding the value of y, I said that because the luminous line is displaced upward, then the value of y will be positive. So whenever the luminous line is displaced upward, so the value of y will be positive, therefore the value of u will be positive. So whenever the luminous line is displaced upward, the voltage u measured by the oscilloscope is positive. Now suppose that the luminous line in this case is displaced downward, like this. Then in this case, the voltage measured by the oscilloscope is negative because the luminous line is displaced downward. Let me write this also. If the luminous line then the oscilloscope measures negative value, which means that u is negative. Finally, the last idea, which is given by number 10. Before using the oscilloscope, the luminous line must be adjusted at the center of the screen in order for the measurement to be correct. So before we use the oscilloscope to measure the voltage across an electric component, we need to make sure that this luminous line passes through the center of the screen, okay, in order for the measurement to be correct. Okay, so this is it for me in this video, guys. In the next part we will solve some exercises as a direct application on what we have explained.